Hello there, I'm Andrew. Today, we're going to be installing a new NVMe SSD. I'm going to go over how I picked this SSD, the installation process, and then we'll do a little benchmarking at the end. First, if you're a returning subscriber, thanks so much for your continued support. If you're not subscribed and you enjoy the video, please subscribe and hit the notification bell so you don't miss the next one. Okay, so first off is picking the SSD. You'll want to match the performance to your use case. You can get an NVMe drive that doesn't have DRAM, that you're just going to use for storage at a lower price point. I've gone with a drive that offers better sustained write performance that's going to help out with my content creation. What's interesting is that the next generation game consoles are also using NVMe technology. The new Xbox and PS5, it'll be interesting to see how that affects the market in terms of pricing. Now, it's important to remember that M.2 is the form factor, not the storage protocol. It can be confusing. Essentially, if you want the fastest speeds, you'll be looking at PCIe Gen 4, although those drives right now are kind of expensive, and your motherboard does need to support that PCIe Gen 4. On the slower end, there are SATA M.2 drives, but their speeds are more in line with traditional 2.5-inch SATA SSDs. Just remember, ABC, always be checking your motherboard manual. For example, I've got a Z97 motherboard that does have an M.2 slot, but it only reads at SATA Express speeds.
And here's a small chart taken from Wikipedia just to show the different speeds of each SATA revision. As you can see, there's about a doubling of speed every few years. And right now we're using NVMe 3.0, which I've highlighted. And you can see it was introduced in 2013, but just now it's starting to get to affordable consumer pricing for drives. And as you can see in 2017, NVMe PCIe 4.0 came out, and already we're seeing some drives, PCIe Express 4.0, that are still more expensive than 3.0, but are definitely coming down in price if your motherboard supports it.
So to get the best speeds possible on my motherboard, I'm going to need one of these, a PCIe adapter. It's under $10 and will help me reach the full speeds of this drive. This is a relatively new drive from SK Hynix. In performance tests, it matches or even beats some of the offerings from other prosumer drives like the Samsung Evo. SK Hynix is interesting because, similar to Samsung, they have full vertical integration of their drives. And what that means is they make the memory chips and the memory controllers, so they're able to offer better speeds and, in this case, better power efficiency compared to other manufacturers who just buy the memory chips and the controllers separately and combine them to make their own drives. This was also at a good price point during Black Friday. Not quite as expensive as the Samsung drives, but at similar performance, and it performs a bit better than cheaper drives. Okay, with the background out of the way, let's move on to the installation. It should be pretty easy with no cables, but those are famous last words. The first thing you always want to do is back up your data. I'm going to be copying an old SSD onto this NVMe SSD, so I'll definitely want to back up that old SSD first, just in case there are any hiccups.
Okay, so here we are in Windows. Hit the Windows key and type backup, and it pulls up the settings menu, and then we'll click on this Windows 7 backup. I've already set this up in the past, so we'll just let this go and back up our drive that we're cloning over. All right, we'll just let this run. It's going to back up on a big external drive so that if we run into any issues, we can just pull up the image of the old drive and we'll be good to go.
You'll also want to use a 4x PCIe slot. My motherboard doesn't have any 4x slots, so I'll be putting it into an 8x slot.
And just to clarify, here's a picture of my motherboard, and you can see the bottom slot is a physical 16x slot. However, logically, it's an 8x slot.
Now, what that means is it's going to share bandwidth with my graphics card, but the graphics card really isn't going to saturate that full x16 slot. It's going to hit that 8x slot. So when the 4X NVMe SSD shares the bandwidth with the graphics card, it's really not going to be an issue on my motherboard. But as always, check your own motherboard manual.
Okay, so we're getting into the installation here. We'll open up the adapter card box. Comes with a little smaller bracket if your case is smaller, if you have a smaller slot, as well as the brass rings and retaining screws for the installation of the NVMe SSD. Here's the card. Okay, let's open up the SSD. Packaging, biodegradable, warranty, manual. Okay, let's open it up. It's crazy how small these drives are. It's really no bigger than a stick of gum. Cool. And I saw some people complaining about the green PCB, but it's really not going to be seen inside the case, so I'm not really worried about it. Okay, let's pop it into the slot. It kind of goes in at like a 45-degree angle. Gently push it in and push it down. Next, we'll use the brass retainer. It slots in the back. And we'll put the screw in. Nice. Looks good. It's going to go in backwards, kind of like that. So you won't even see the green SSD. Next, we're opening up the case by removing thumb screws. And you can see the scene of the crime. So I've just made a little chicken scratch diagram here to show what is in each slot, just for my own peace of mind to help me during installation. We're going to have to rearrange some components. So I'm taking out my capture card and moving it to a 1X slot up top. And we're moving the Wi-Fi card underneath the graphics card for a little bit better airflow so it doesn't block the fans on the graphics card. Next is the SSD, and we'll pop it in to this slot here. Make sure it lines up with the bracket and gently push in until you hear a soft click. There we go. Thumb screws to hold it in place, and that's about it for physical installation.
Right, so let's boot into Windows and copy the drive over.
So this is the tool I'm using, Macrium software. It comes with SK Hynix drive, so we'll just download that and install it. There's a user guide you can read through. Here is the tool, and we're just gonna start this. Now this is very important. Make sure you select the proper disk, the target and the destination. Otherwise, you will write over data. Okay, we'll check this. This all looks good. It's going to copy over all of the partitions and hidden partitions. And just to confirm, I'll pull up disk management. See, it's saying it's not initialized, but that's okay. It will be once we copy over the old drive to the new drive. And you can see here, it's directly copying these hidden partitions, so we won't need to format or initialize the new drive. Okay, looks good. So now we're going to hit start, and we will let this run. We'll check back in a few. Awesome. Clone completed. Yeah, it only took less than an hour. Not bad. If you want, you can view your logs, but we're going to finish and move on. Okay, so now we can see that this G drive, it is copied over with the contents of the old C drive, but we did not boot into it.
Once your OS drive has been copied over to the NVMe drive, we'll need to go into the BIOS and set your boot order so that your motherboard knows which drive to look at, so it knows where to find Windows and which operating system to boot into.
Okay, so here we are. Check your motherboard manual for the button you need to press to get into your BIOS. Here's the boot order. You can see all the way down at the bottom is our new drive, SK Hynix Gold P31 1 terabyte. All right, let's enter the setup. Okay, and here is the graphical interface. I'm going to go over to the classic interface because it's a little bit easier to show. Here we are, system info, BIOS features. And first, I do want to mention that you should check your BIOS version because some older BIOS versions don't allow you to boot to an NVMe drive. So it's really important to check that and check your motherboard manufacturer's website for guidance on how to do that. And down the bottom, peripheral NVMe configuration, you can see that our drive is being registered there. So that's good. And now let's actually set the boot sequence. This is a cool kind of drag and drop interface. We're going to check the names of the drives. You saw Mac on there. I do have multi-beast setup. Click and drag this Windows Boot Manager drive all the way to the front, and we should be good to go. Save and exit. All right, great. And now we can see, no pun intended, the new C drive. It's the 1 terabyte drive, and here's the old 500 gigabyte drive. So let's go into disk management here and check it out. There's our C drive up top. It mirrors our old hard drive. There we go, disk 4 and then disk 0 up there. So everything matches except for our NTFS partition has a little bit more breathing room. And you can't tell from this, but is much faster. Now, one thing you can see here, just to verify, disk 4, it has the boot crash dump tags in there under your NTFS partition. That tells you that it's your primary drive, your C drive for your Windows.
Okay, and now we're in and it looks good. We verified our install, and now let's move on to some benchmarking.
Okay, so here we have a little benchmark tool, Crystal Disk Mark. You can just get it for free on there if you just Google search it. And we're just going to run this, let it run. And I'm also going to pull up Crystal Disk Info to show you the thermals while it's going. You can see it's only been on for 2 hours. Pretty interesting info. And so you can see our final results here. Pretty good read and write speeds. This is about 6 times what I was getting from my SATA SSD. And you can see the temperature here dropped about 10 degrees after the benchmark. Still within safe operating temperature.
Okay, and now that we're happy with the drive, I'm going to format the old drive, and so we can use that for some game storage.
Okay, so back into disk management we go. Now, if we right-click on this and change the drive letter, I'm just going to change this because I have an external drive that uses the G letter. So we'll make this H drive here. Just hit yes on this. And it says it's in use, but that's okay. Just hit yes. We're not really using it for anything. Okay, and here we have the H drive, which was our original C drive. So what we'll do is right-click on this PC, Advanced System Settings, Performance, Advanced, and we'll need to change virtual memory. And here on the H drive, I've already done this, but you'll just want to select no paging file. And of course, I guess you can add it back later after you've cleared out the drive. But once we're done that, we can format it. And I've renamed it so I can better identify the drive. And one more thing, you can go into the command line and remove these other recovery partitions, but I decided it's only about 1 gigabyte taking up space. And if I ever run into any issues on my new disk 4 down the bottom C drive, I'll have a backup on disk 0, the old SSD, just in case we run into any issues further on down the line.
Well, that about wraps it up for today. I hope you enjoyed the video. If you found it helpful, leave a like and consider subscribing to help support the channel. Tell me in the comments below, are you using an NVMe SSD too? Which form factor did you go with, and which drive? Alright, thanks for joining me today. Again, I'm Andrew, and we'll see you in the next video.